Okay, we're just going to do a quick review for the test so that you're ready for it. The first questions say, fill in the requested information, then graph the function, make sure you plot at least 5 points. So on this first one, I'm going to find the vertex. Notice that it's already in vertex form, so the vertex is opposite of what's in parentheses, comma, what's at the end. Remember, axis of symmetry is always x equals, and it's what the x value of the vertex equals. So in our case, x equals -2. The direction it's opening comes from the front of our equation, and we see that it's positive, so this is opening up. Now if we want to plot 5 points, remember our easiest way is to make a table, putting our vertex in the middle, and we do 2 smaller numbers and 2 bigger numbers. When we have that, we can take -4 and plug it into x. When I plug -4 into x in my calculator, I get 12. We know our parabola is symmetric, so 0 is also going to be 12. We're going to do it again for -3. We plug -3 in for x and solve. When we plug in -3, we get out 6. Okay, so now that we have our points, we want to plot it. -4, 12 is a little too high. -3, 6 is here. -2, 4. -1, 6. And 0, 12 is too high. On your test, make sure you plot 5 points. If I ask you to plot 5, 5 will fit. Then you draw your parabola. For our next one, we have our graph in standard form. Remember, to find the vertex in standard form, we have to start with -b over 2a. Our b is -12. -12 is +12 over 2 times a, which is 2. 12 over 2 times 2 is 12 over 4. 12 over 4 is 3. Now I have the x value of my vertex. To find the y value, I have to take x and plug it in. So it's 2 times 3 squared minus 12 times 3 plus 19. I can just plug that into my calculator, and when you do, it comes out to 1. That means your axis of symmetry is x equals the x value, 3, and it's opening up because our front value is positive. Now when I make my table, I put my vertex in the middle, I put 2 smaller numbers, 2 bigger numbers, and I plug into my calculator. When I plug in 1 into my x's, I get out 9. Since it's symmetric, when I plug in 5, I also get out 9. When I plug 2 in, I get out 3. Again, the symmetry makes 4 also yield 3 when you plug it in for x. Then I can plot my points. Once again, I did not do a great job of making this fit. 2, 3, 3, 1, 4, 3, 5, 9, and we can draw our parabola. Okay, the next section says to find the zeros, real or imaginary, and y-intercept of each function. Make sure to show your work. So let's start with the zeros. Zeros are the same thing as the x-intercept. We know that the x-intercept is when we plug in 0 for y. This one's awesome because it's already factored, so I can set each factor equal to 0 and solve. Here I'll have to add 4 to both sides to get x equals 4. This one I'll need to subtract 1 and divide by 2 to get x equals -1/2. Remember, we like our answers written as coordinates, so 4, 0 and -1/2, 0. The y-intercept is the easier part, remember. This is where we plug in 0 for x, and then we plug it into our calculator. When you plug that into your calculator, you get out -12. Remember, we like it as a coordinate, so it's 0, -12. The next one is in standard form. The x-intercept in standard form, we have to make sure we factor. So I plug in 0 for y, and I get my thinking number, which is -24. I write all the pairs, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Hopefully one of those gives me 2. 4 and 6 do. If I do 6x minus 4x, I drop the -8, I drop the 3x squared, I underline and squiggle. Out of the first ones I can pull out a 3x, leaving me with x plus 2. I drop the negative, I can pull out a 4, also leaving me with x plus 2. So I get 3x minus 4 times x plus 2. Since it equals 0, we can set each factor equal to 0 and solve. Here I'll have to add 4 and divide by 3 and I can write it as a coordinate. Here I have to subtract 2, and I can write it as a coordinate. For the y-intercept, we do the same thing as we did over here. We plug in 0 for x and plug it into our calculator, and I get y equals -8. I can write that as 0, -8 as a coordinate. The last one is in vertex form, so when I find my x-intercept, I write 0 for y, so 0 equals -2 times x minus 3 squared plus 48. I subtract 48 to get -48 equals -2 times x minus 3 squared. Divide by -2. 24 equals x minus 3 squared. I'm going to write it here so I have a little space. I square root both sides, and I get plus or minus root 24 equals x minus 3. I have to break down 24 to see if there are any pairs. There's a pair of 2's, so I get plus or minus 2 root 6 equals x minus 3. I add the 3, and I get 3 plus or minus 2 root 6 equals x. Remember, we like to write these as coordinates, so that's 3 plus 2 root 6, comma 0, 3 minus 2 root 6, comma 0. Now I'm going to come over here for the y-intercept because I'm running out of room. For the y-intercept, I plug in 0 for x, and I plug that into my calculator, and I get y equals 30. I can write that as a coordinate 0, 30. Okay, go. The last section says to solve each inequality. Write your answer in interval notation. Draw a rough sketch of a graph for each problem. Here, to start, I notice it's not a difference of squares, it's not a trinomial, GCF. I can pull out an x, set each piece equal to 0. I can solve for this one by subtracting 3. So now I can plot my points in least to greatest and draw my parabola. Now I look at my sign. It's greater than, so I color above. There are 2 pieces, so there will be 2 answers. -infinity to -3. It's not or equal to, it's just greater than, so parenthesis union 0 to infinity. On the next one, it's a difference of squares. I had noted this because we have a subtraction. 4 is a perfect square, x squared is a perfect square. So I get x plus 2, x minus 2. Set each equal to 0. And solve. So I get x equals -2 and x equals 2. I can plot them on a graph, draw my parabola. It's greater than or equal to, so I color above. I'm going to have 2 pieces colored, so I'll have 2 answers. -infinity to -2. It has an or equal to, so bracket, union, bracket, 2 to infinity. My last one doesn't have a 0 on one side, so I have to make sure I subtract 8. So I get x squared minus 2x minus 8 is less than 0. I have to factor. -8 is my thinking number. 1 and 8, 2 and 4 are my pairs. 2 and 4 make 2. If I have 2x minus 4x, I drop the 8, I drop the x squared, I underline and squiggle. I can pull out an x, leaving me with x plus 2. I drop the negative. I can pull out a 4, leaving me also with x plus 2. So factored, it's x plus 2 times x minus 4. I can set each piece equal to 0 and solve. So I get x equals -2. And I'll have to add 4 to get x equals 4. Now I can draw a graph, plot them in least to greatest, draw my parabola, well, try to make it cross 3 lines, and I color less than, so below. Only 1 piece is colored, so I'm only going to have 1 answer. I use parentheses because it's not or equal to.